we're going to work through your homework tonight so that you'll be prepared for the test tomorrow, and you're going to see there are some pretty big mistakes in your homework. And for once, I'm glad because I didn't make the mistakes. So let's look at number 1. You can pause this video at any time. If you want to work number 1 ahead of me, that's probably a great idea. So if you want to pause, work it, and then check your answer with mine, I'm just saying that's probably a good idea. Trinity drew this shape on grid paper. What is the perimeter of the shape? Remember, perimeter plus, right? We're going to add our way around the shape. Now, there are 2 ways we can do that. We can say, okay, well, I know this is 1, 2, 3 squares across. This is 1. This little armpit right here is 1. 1, 2, 3 squares down. 1, 2, 3 squares down. 1 and 1. So you can do it that way and then add them all together. Or remember that we also just numbered the squares. 1, 2, 3, 4, 5, 6. Remember, this one's got to have 2 numbers in it because there's an armpit. 7, 8, 9, 10, 11, 12, 13, 14. Okay, and that one had to have 2 squares because there was an armpit. Or we can just add them together. 3, 6, 9, 10. Wait a minute. Have I already made a mistake? Let's see, this was 3 across, right? I'm just checking to add. This is 1. This little armpit here is 1. This is 1, 2, 3. 1, 1, 2, 3. This is 1, and this is 1. So that's 3, 6, 9, 10, 11, 12, 13, 14. Okay, yeah. It was 14 units. Whew, thought I worked it wrong. Now I know you're going to say, Miss Wise, number 2 is here, but my little setup that I'm using here, it's going to be easier for me to work straight across. Ian is building a rectangular sandbox. The perimeter will be 12 feet. He wants the sandbox to have the greatest possible area. What could be Ian's sandbox? Okay, remember that area equals length times width. Now, when they give us the unit squares, we can literally just count them, right? So this would either be 1, 2, 3, 4, 5 times 1, right? Because there's 5 here and 1 across, and 5 times 1 is 5. Or you can literally just count them and say, okay, well, I know the area is 5. Okay, this is 2, 4, 6, 8. This area is 8. Or I could say 4 times 2. I'll get the same answer. 3, 6, 9. Or I can say 3 times 3. 2, 4, 6, 8, 10, 12. Okay, or I can say 6 times 2 because this is 6 across and this is 2 down. So which one has the greatest area? 5, 8, 9, 12. Right. Okay. I don't know that name. I'm going to call it Lane. Is placing tiles on the floor of an office lobby. Each tile is 1 square foot. The diagram shows the lobby. What is the area of the lobby? Okay, well, remember, there are 2 ways to calculate area. I can say length times width. So 1, 2, 3, 4, 5 times 1, 2, 3, 4. I can say 5 times 4 is 20, or since it has the unit squares, I can literally just count them. 1, 2, 3, 4, 5. Oh, why not count by 5s? It's faster. 5, 10, 15, 20. Okay, Bailey draws this shape. How many right angles does Bailey's shape appear to have? And our choices are 0, 1, 2, and 4. Well, Bailey has drawn a square, so we can think about our definition of a square, right? And we know that these little squares on the inside also indicate right angles. So 4, okay? And yes, squares do have 4 right angles. They're made up of 2 sets of perpendicular lines, and all the sides are the same length. Number 5. Aaron put square tiles down in his kitchen. He drew this sketch. Each tile is 1 square foot. Okay, so we know that area equals length times width. 9. So area equals 9 times 6, okay, is 54. Or I can literally count them. Since there are so many, I actually don't want to count them. So I'm just going to go with that. But if you did not know what the product of 9 times 6 is, you could literally just count them and, until you get to the end, and then you would end up with 54 square feet. I hope you're pausing these and trying to work them and make sure that you're at least attempting to jog your memory by working these before I do. All right, let's go to the next page. So with number 6, we come to the first mistake. It says, Rebecca drew the shape of her yard on dot paper. Rebecca's yard is not a regular polygon. We don't know how to calculate the shape of an irregular polygon because I would have to put it on an XY axis and plot the points. So let's just talk about how we find area. Remember that area is length times width. You can see it won't work because there are a lot of different numbers here, right? Area, length times width works for regular polygons, squares, and rectangles. So we really can't answer this question. I just want to remind you that we would take, if it were a rectangle, that was like, let's say 5 and 2. Okay, do you know what the area of a rectangle that has a length of 5 and a width of 2 would be? Right, we would say 5 times 2 is 10 square units. That picture is some kind of advanced math that I am not going to teach you in 3rd grade. I had to look it up myself how to do it. Okay, there's another problem on number 7. Good gravy, who proofread this book? Okay, it says Leah made this drawing of a garden she is planning. I'm pretty sure Leah's garden is not an angle. Okay, so it says which shows the area of Leah's garden. Well, again, area is length times width. And what they've given us is an angle. But let's take this opportunity to talk about what kind of angle that is. Is it a right angle, an acute angle, an obtuse angle, or a straight angle? Right, this would be an acute angle. Good gravy. I think that was the last of the mistakes, if I remember correctly. Okay, number 8. Alexander wants to put a ribbon around this tile. Around, so that makes me think we're probably talking about perimeter. The question is up here. How many inches of ribbon does Alexander need for the perimeter of the tile? So we have 4 plus 4 plus 4 plus 4. Since this happens to be a square, we can say, okay, we have 4 groups of 4 and, make it 16. Or you can just literally add all the 4s up and get 16. Okay. Now, on number 9, it's going to take a minute. Oh yeah, there's a little bit of a boo-boo on number 9 as well. We're gonna have to figure out the area and perimeter of all of these to find our answer. Yes, my dear, all of these. It's gonna take a minute, okay? You gotta be patient. So let's find the area of this one. I can literally do length times width. 1, 2, 3, 4, 5, 6 across. And 3 down is 18. Or I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? Now remember, perimeter, I prefer to do perimeter like this, where there's, I know it's 6 on this side, right? It's 6 across this way. So that means it's got to be 6 on the bottom. And since it's a rectangle, since it goes down 3 this way, and then 3 this way. So I would say 6 and 6 is 12. 12 plus 3 is 15. 15 plus 3 is 18. So the perimeter of this would be 18. Now, for those of you who prefer, of course you can go count around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so you'll see I still got the same perimeter if I counted all the way around the shape. To me, use whatever strategy you prefer. I kind of prefer the addition strategy because I feel like I'm less likely to make a mistake. But now, hold the phone because we've got to find the area and perimeter of all of these rectangles. We want one that has the same area, so it's got to have 18 as an area, but it's got to have a greater perimeter. Okay, so let's just count it for the sake. For area, since I can just count it, let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, there are 2 rows of 9, so that's 18. Hey, we've already found one that has the same area. But wait, we have to do the perimeter. Okay, I would prefer to do 9 plus 9 plus 2 plus 2. But let's go ahead and count through it. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so it has a perimeter of 22. Now, I really like that because the area is the same and the perimeter is greater. But wait, there's more. Okay, so for rectangle B, it's a long, skinny guy. Okay, the area is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, I like that. It has the same area. Now, let's see if it has a greater perimeter. Okay, so since it's 18 across, it's 18 this way, it's 18 this way. 18 plus 18 is 36. There's 1 this way and 1 this way. 36, 37, 38. So you see, that one also works. Let's look at the next one. Let's count the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nope. It does not have the same area. I don't need to calculate the perimeter. I can stop right there. 1, 2, let's figure out the area of this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nope. It had to have an area of 18 to have the same area. Now, there are 2 answers here, right? I don't think that the book people paid much attention to this at all. So I'm going to go ahead and circle B because it happens to have the highest perimeter. There are no mistakes like this on your test. I've already worked the test and put it online, so don't worry about that. It's very straightforward. Number 10, Adam draws a hexagon. Oh, how many sides on a hexagon do you remember? 6. Each side of his hexagon has the same length. The perimeter of the hexagon is 36 inches. What is the length of each side of the hexagon? Okay, so something times 6.
Hi, I was here to check on your toilet. I'm sorry, I can't hear you. They said you were having a problem with your toilet? It's fixed now?
Yeah, it's fixed. I'm sorry, I'm recording a lesson, but it's fine.
But no, it's fine. If someone came in and worked on it, it's working fine.
Okay. Did you need a meal tonight?
No, not tonight.
Okay.
Thank you.
Okay,
I'm sorry, I didn't do that.
I know. All right, so good gravy. So let's pretend, I'm sorry about the interruption. At the hotel, our toilet wasn't working, so they sent somebody up. What is the length of each side of the hexagon? So let's say I don't know. Okay, I do know that the whole perimeter is 36. And it gives me 4 things to try. Okay, let's try 5 inches. Okay, 5, 10, 15, 20, 25, 30. Nope, that won't work. Let's try 9 inches. 9, 18, 27, 36, 45, 54. Nope, that won't work. Let's try 6. 6, 12, 18, 24, 30, 24. Oh, I'm having a moment. 30, 36. There we go. There we go. And then it couldn't be 12, right? Because 12 and 12 is 24. 24 plus 12 is 36. So, all right, on to the next page. Maybe we're finished with mistakes. Maybe. Okay, number 11. Liam draws this shape. Okay, so it's a trapezoid. What is the perimeter of Liam's shape? Remember perimeter plus. So we're going to add our way around the shape. So 2, 4, 6 plus 1 is 7. So I got 7 units. Oh, 7 feet. It tells me what units. Okay, well, there you go. 7 feet right there. Number 13. Carolyn drew this angle. What type of angle did Carolyn draw? A right angle? No, a right angle would be straight up and down and would have this. So it can't be a right angle. A straight angle? No, a straight angle would go straight out like this and it would equal 180 degrees. An obtuse angle? I do like that. Look, see, it's stretched out just a little bit further than a right angle would be. An acute angle? No. If it was acute, it would have landed somewhere over here. So yes, it is an obtuse angle. Okay, let's go and do number 14. Hayden has 24 feet of fencing. He wants to build an enclosure for his dog. Hayden wants the enclosure to have the greatest possible area. Which length and width should Hayden use for the enclosure? Okay, this one's kind of a difficult one. This is a real world thinking problem. So we wanted to have the greatest possible area. Okay, this dog needs room to move around. So let's think about 3 feet and 9 feet. Okay, so it would be like 3 feet this way and 9 feet that way, right? Oh, that won't actually work, right? Are we talking? Oh, yeah, it will, because we're talking about the fence he has. Wait a minute, let me think about this. The greatest possible area. Okay, yeah. All right, so this is saying 9 and 9 is 18. 18 plus 3 is 21. And then 21 plus 3 is 24. But think about that dog. He's got just a little bit of room this way. He can run a long way this way, but he can't really go very far in this direction. So let's say 4 feet and 8 feet. So we're spacing it out a little bit more, right? We got a little bit more room. Okay, 4 feet, 8 feet. If you add that up, that all equals 24. Okay, so he's got a little more room. I like it. So far, that's better. 5 feet and 7 feet. Oh, I think that would be even better because then he would have more room to move. He's got a little bit more room from here to here to go this direction. But let's look at the next one. So we're going to go another foot out, but we're going to lose a foot. Okay. So we've got 7 and 7 and 5 and 5. Okay, so this one's actually better than this one. But look at this one. I think this one's going to be the best because this one's 6 and 6. So he can move 6 feet in this direction and 6 feet in this direction. So you may have to make a little sketch if you have one on your test like that. I don't remember seeing one, but I did that on Saturday, so I could have forgotten. But if that happens, just make a sketch and try to think about it the best you can. Okay, a rectangular bookmark has a perimeter of 16 inches. The length of the bookmark is 6 inches. Okay, so we've got 6 and 6 here, and we don't know what these two ends are, right? There's N, the letter N, and the letter N. So I'm going to think the total perimeter is 16 inches. I know 12 of those inches. So, because 6 plus 6 is 12. So, I think I could subtract. Okay, and that gets me 4. But now I need to think about that. Okay, because I have to share 4 between this side and this side, right? Because I have 2 ends. So I need to take half of 4, right? And share it with the 2 ends. So, yeah, what is the width of the bookmark? It's 2 inches. See, they're trying to be sneaky. Once you see that 4, they're like, oh yeah, the kids are going to circle that. But we've got to think, since there are 2 variables, we don't know what either of these ends are. We've got to share that number equally. We're almost done. Dominic is painting a mural on a wall. He divides the area into sections that are 1 square foot. The diagram shows the space where Dominic will paint the mural. What is the area of the mural? Okay, now this is not a regular polygon, but it has unit squares in it. So we can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square feet. Number 16. Brooke drew the shape of her bedroom on grid paper. Her bedroom has 4 sides. 2 sides are 10 units long, and 2 sides are 8 units long. What is the perimeter of Brooke's bedroom? So I'm just going to draw a rectangle here. I know it's a rectangle because it's the width, or the length, I'm sorry. The length is 10 and the width is 8. It's not a square because if it was, all of the sides would be the same. Okay, so 10. Okay. 2 sides are 10 units long. So there's my 2 10 units. And 2 sides are 8 units long. Okay, 10 plus 10 is 20. 8 plus 8 is 16. So it is 36 units. Okay, number 19. Isaac drew 2 rectangles on grid paper. Which statement is true about the perimeters and areas of Isaac's rectangle? Okay, which statement about the perimeters and area of Isaac's rectangles is true? Now, you guys, I know some of you like to get lazy here. You're going to have to figure out the area and perimeter of both of these. Okay, you can do it. It's just going to take a little bit of time. So let's call this one A, and we'll call this one B. So the area is 1, 2, 3, 4 times 1, 2, 3, 4. Okay, so the area of that is 16. Now let's figure out the perimeter. Remember, perimeter is plus. We're going to add our way around it. So this is 4, this is 4, this is 4, and this is 4. So the perimeter is also 16. Now let's figure out for B. The area is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2. 1, 2. So 16. So hey, the areas are the same. Now let's check out the perimeter. So this is 8. So this side is 8. And this is 2. So this side is 2. 8 plus 8 is 16. Plus 2 is 18. Plus 2 is 20. Okay, so they have the same area, but their perimeters are different. So now we're going to have to check each one of these statements and see which one's true. The areas are the same and the perimeters are the same. No, that won't work because the perimeters are not the same. The areas are different and the perimeters are different. That won't work because the areas are not different. The areas are different and the perimeters are the same. I like that. The areas are the same. Oh, wait, no, that won't. I shouldn't like that. Did you catch that? I should not like that. The areas are the same. The areas are the same and the perimeters are different. Yes, that's the one I should like. Whoops. Number 17. The drawing represents the living room in the Garcia's house. Each unit square is 1 square yard. What is the area of the Garcia's living room? 1, 2, 3, 4, 5. So I can count each row by 5s. 5, 10, 15, 20, 25. Is that right? It is so dark in here, guys. 5, 10, 15, 20, 25. Okay. Yeah. Well, of course it would be because it's 5 by 5. 5 times 5 is 25. Number 18. Jenna drew a sketch of the sandbox at the park. What is the area of the sandbox? Remember, this is where we had to connect the dots to make unit squares. Okay, and so we can either multiply the length times the width. 3 times 3 is 9, or you can literally count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 square units. And finally, number 20. Gabriella draws this picture of her photo frame, which shows the area of Gabriella's photo frame. Okay, remember, area equals length times width. So the area equals 10 times 8. Remember, it doesn't matter which factor you put first, you'll get the same answer. So the area equals 80 square inches. Okay, gang, test is tomorrow. Do your best. Take your time. I know you can rock it. And I will talk to you tomorrow.